So for tutorial 2, what you need to do is right click, save link as, and save it in a place where you can find it. Now this is showing a weird thing. So right click, save link as, and I'm not sure why that thing is coming if it's showing up in a different name. I don't have an internet connection. That's probably the reason. 2 seconds. Let me just check if the recording's on. Yep. All right. So what you need to do is, if you have opened the thing, you can hit Control S and save, or you can right click and say save as, and now it's giving a, I don't know why it's saying that, but probably. So over here, let's refresh this. If you have anything weird coming up, try reopening. Okay, now it's fine. Tutorial 2 txt, open that file. Now I have Notepad++, okay, which is a fancy text editor. You don't need Notepad++. You can use plain Notepad if you're on a Windows machine. You can use TextEdit if you're on a Mac. Just make sure you are editing a text file. All right. So question 1, I'm not going to read through the whole thing. Basically, follow this demonstration on how to do it. You have to find a different example. So let's open up Eclipse, which I probably have over here. I keep all of my stuff portable whenever possible. I don't want to mess up my Windows registry. All right, so we are on Thursday, so that's fine. And let's try to find some examples. So in the video I said Java tutorials. So anyway you type, search for tutorials, Java tutorials, either way, you can come across tons of examples. All right, so in the video I went to Tutorials Point, which is a reasonable website for these sorts of things, and the exact example I showed was probably not that one, this fresh juice test one. So I'm going to do something completely different to that, okay? And the reason is you have to do something different. That's one of the things. And the other thing is you need to be able to find your own examples. We are learning, or you are learning technology. You are not learning history. History doesn't change. With technology, you'll need to find out things, research things on your own. Once you go to work as a programmer, when you are applying for a 6-digit job, right? It's going to pay you a 6-digit salary. Nobody's going to come over and tell you, here you go, this is what you need to look at. Nobody's going to do that. You need to have these skills developed, right? So that's what we are trying to help you do. Maybe by the time you graduate, people will not be using Java. That's the reality of these things. What are you going to do with what are you going to do if you don't have the skills to investigate and learn? All right, so we go to Eclipse. Now if you don't have any of these windows, it's not a problem. All right, so let's say you have none of these things. You can always go to Window and show View, and you can get the Package Explorer or the Project Explorer. Either way, they're very similar for what we are doing. So to add a new project, we right click on this, we say New Project. Okay, so we are looking for Java projects, so we can choose Java project there. Your menus might be slightly different, but anyway, we want to add a Java project, not a JPA project or anything else. So give the project a name. Okay, so week 2 Friday, that's what I'm going to, sorry, no, this is Thursday. And the exact name in that was slightly different, but that's okay. Now, how do I add a program to this one? What do I do next? I add a new class. So where am I adding a new class to? To this project. So every time you write a new Java program, you need to add it to a project. You create the project first, then you say class. So you right click on the project to which you want to add the new class, then you choose the class. Right, the name of the class, that's pretty important. You can't just come up with any name you like. What's the name you want? How do we decide on the name? it depends on the name of the existing program. If you remember the fresh juice test video, or in the video I showed that one. What's the name I chose? It's which one was it? I can't remember anyway. So here we go. It was somewhere up here. Basic syntax. Page up. Here. So when I did this, which name did I use for the class? Was it this one? Was it the first one? Was it the second one? It's like an eye test, isn't it? Which one is better? The first one or the second one? Which one is the right one? The second one. Why is that? Sorry? I gave an example. It's the one that has the main method, or this public static void main business. Now, you don't need to know everything about Java. All you need to remember is you did a hello world program and it worked. All right. So what did the hello world program have? It didn't have this additional class. It had this part, public class hello world, and then it had this business, right? And the first line, that line, and then it had the close brackets, and it had one more line, the print statement, right? So that was one of the smallest possible Java programs you could ever write, and it had this stuff here. These things were there, so it should give you a hint that okay, that's probably the most important thing. That's how you pick which class is the most important. All right, so we pick the class that has the main of the public static void main. Okay, so you right click and copy and put it into this one. But in this case, we are doing a different example. We are looking at something I didn't show in the demonstration. This one. Okay, let's copy this whole thing over. Yeah, but so the name is going to be what? This test. Why? Because that's the name of the class that contains the void main, or the public static void main. Okay, so why do we say contains? Because if you look at the brackets, right? See, for every open bracket, there is a closed bracket, and these are all like hierarchical. They're put inside each other, right? So you get this public class test open bracket, and this is the corresponding closed bracket right at the end for that public class test. Okay, so everything else is now inside it. You can actually collapse it and turn it into a single line. This is one component that's inside public class test. This is another one that's inside public class test. So we know that we have this public static void main here. That's why we are interested in this class name. Okay, so that's the class name that you have to put. Now, what's the problem here? If I type it like that, it's not the same name because it's case sensitive. It's very pedantic. Let's put it that way. All right. Now, do I need to click this one? Public static void main. Can I see hands for yes? Can I see hands for no? A few people? All right. It doesn't make a difference. Either way, we are going to replace the whole thing. So you can keep it in there, or even if you don't want to keep it, that's fine, because we are going to take this whole program, this thing, and copy it, go over here, erase everything, paste. Okay, now the next thing. What's the next thing that we do normally? If you were listening carefully last week, yeah? Source and format. Or you can just press Ctrl-Shift-F. If I did that, you won't see what I pressed, but do that at all times. Okay, so it also sometimes highlights errors visually. Okay, so right now we don't have any errors. We know that because there are no red dots along this, so it's looking good. There are no worrying red exclamation marks or anything. We can run this thing and it works. So this is what I wanted to see if you could do. Okay, so puppy age, I saw a few people do this exact same example. All right, so there are tons of examples out there. You should be able to learn from those examples. So the URL in this case should be the place where you got the example from. That's it. That's all you needed to do for that question. Moving on to question 2. Break something, break one thing at a time, and say what caused it. Okay, so let's play a game. You have line numbers up to 13 even. Name the line and the thing to break. Who wants to go first? Name a line. Line number 9. Okay, what do you want to break on 9? Sorry? The brackets. Which bracket? This bracket? Just one of them. I'll break just one thing. Okay? Alright, so now when I did that, just like in a word processor, it's underlining something that's wrong. Okay? Sorry, was there a hand up?
Yeah.
Yeah?
Line 8.
Or did you say line 8?
Yeah, delete the L.
Yeah, okay, we'll do that next. So we'll fix this. Now I'll keep that in mind. So syntax error on token test, comma, bracket expected after this token. So that's exactly what you should be writing. Okay, so syntax error on token test. Syntax error on token test. Bracket expected after this token, I think. I hate this auto suggestion stuff, right? Okay, so let's fix that back up. And line 8, which one? What did you want to break?
L.
Line. Oh, right. Oh, no. No. I've been programming in Java for too long to know where you're going. All right, something else. All right, the B, right? So anyway, so syntax error on token, public, all right, public expected. All right, so wait, what caused this one? The removal of the, that's it. Okay, so this one is saying syntax error on token, what is it saying now? Public, public expected. All right, so just like what the error says, when public was replaced with public. All right, let's fix that up. Okay, name a line number and the thing to break. Who wants to go next? What's the line number?
1.
Line number 1. What do you want to break?
Change public to private.
Yep. So that's a sort of a syntax error, I suppose. But anyway, we get an error anyway. So illegal modifier for the class test, only public, abstract, and final are permitted. Let's try to see if I can remember that. Illegal modifier for the class test. Illegal modifier for the class test. Was that a full stop? No, semicolon. After public, only public, abstract, and final are permitted. Only public, abstract, and final are permitted. All right, cool. So what caused it? Replacing public of public class with private. So that's what caused it. Good, right? All right, what else? Name the line number and the thing to break. In line 5? Yep.
Change the code to a 9.
This one? Yeah. So this was actually in the exercises last week. So method print in string is undefined for the type print string. Right. The method print in string. Okay, so the method print in inside bracket string is undefined for the type print stream, for the type print stream. So now what caused it? Writing print in instead of print ln. Okay, so that's what caused it. Now I'm not expecting you to remember these error messages. In fact, I don't remember some of these things. But the important thing is, if you get an error message, don't freak out. Take a deep breath, fix it. Read the error message. Most of the time, it'll tell you what's sort of causing it. Okay, so when you keep the mouse over, we get some description. See, syntax error on token test. Here it said the bracket was expected. Okay, so that should be fairly self-explanatory. And this sort of thing, it tells you public expected and illegal modify the class, only public, abstract, and final are permitted. So it tells you what you need to put. Right, one last thing. Name the line number. 12. Line number 12. Yep. Get rid of the bracket. Okay, so that's one thing we can do. We can also add an extra bracket. Okay, so let's get rid of the bracket. So if you get rid of the bracket there, you'll get an error message here on line 11, syntax error, insert to complete class body. Okay, syntax error, insert to complete class body. Okay, so cause removal of from class. Okay, so that was the final close bracket. That's what we removed. And even if you, so there are so many ways in which you can break a program. On Friday, I showed the Hello World program, and I showed how many different error messages from just the Hello World? 14 different things. There's more. Okay, you can get so many different error messages from even a little program. But when you get an error message, don't freak out. Just you can even search for it. You can search online to see what it means, but most of the time just reading the question or reading the error message is enough to fix it. Question 3 is saying, search for what is meant by a variable in programming. Write a few sentences to explain it in your own words. So let's try to search for something. What does variable mean? So if you search for variable just like that, you'll get all kinds of answers. Now again, this is investigative learning. We are not saying that everything out there is accurate for you to use. We are not telling you to use the first one. It's just like in real life. If you're going to buy something, I've used this analogy before. If you're going to buy a laptop, do you just go to the nearest store and pick up the first laptop that's closest to your hand? No, you don't, right? You shop around. You go to different stores. You look around. You see what common features are there for the price you are paying. You can do the exact same thing when you're looking for answers online. So I have the Wikipedia article coming up. There is a website called Math is Fun, and there is a video. I'm not going to go into that. There is a business directory. All right. Now I might add another thing here and say variable in the context of programming. So I'll just say variable programming, and here's one, and here's one. All right, you open a few, you have a look at a few places. All right, so now this is taken to the main page for variable, so we want to go into the computer science one. So yeah, all right, so now this one says in computer science a variable or a scalar is a storage location paired with an associated symbolic name, an identifier which contains some known or unknown quantity of information referred to as a value, and your head explodes right there. Right, because that's just not a friendly explanation, but you just keep it there. All right, so you move on to this one. Now this says math is fun, and it says a symbol for a number we don't know yet. It is usually a letter like X or Y. Now the problem with this source is it's not in the context of programming, it's in the context of math, so you need to stretch it a little bit. So we don't want that sort of thing, so you get rid of that, move on. All right, what's this one? This one is again saying a characteristic number or quantity that increases or decreases over time or takes different values in different situations. Now that's close, but unfortunately this is from business school. All right, we are not in business school, and well, it's not bad. They all have the same idea, but we are talking about the context of programming. All right, so variables. What is a variable? Variables are used to store information to be referenced and manipulated in a computer program. All right, okay, we'll keep that. We'll hang on to that. A third resource is saying a variable is a symbolic name for information, right? And the variable's name represents what information the variable contains. Okay, so now we have three sources. Let's take a look at what's common. Okay, how much RAM you get, what kind of a hard disk you get for you are shopping around, right? Just like you're shopping around for a laptop. All right, so in this one it said storage location. Okay, so it's used the word location. Let's see whether the word location is mentioned in other ones. So variables are used to store information. Let's see, not so much about location here. Here we go. It's telling you the location is memory. Okay, so it's saying that there is a location. This is a variable represents, they are called variables because they can change in general and so on and so on. So this one doesn't use the word location, but the location concept appeared in a few places. So that's telling you that, okay, it's some kind of a location, right? And so you shop around. What else is common? Okay, so this one says there's a name, and this one says labeling data. That's the same concept, giving it a name. Variable's name. All right, so there you go. Name, location, two things. That's common across different explanations. What else? So we can start our explanation right now. It's a location with a name and contains blah 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 information. It's a container, right? It can store and information can be, we can reference what information contains. Here we go. So I didn't rehearse this. Okay, this is basically what showed up on Google today, right? And that's how you should find out. So this one says information is contained. So contained, store, contain. So you can say it's a location with a name which can store or contain information. There you go. You found your answer. You don't have to wait for the definitive place which has the perfect answers. You can shop around. All right. So it's a skill. There's no right or wrong answer. Sometimes you have to develop this skill. So it's a location with a name which can contain information. Where is it? Now let's just gather up answers from what you all have come across. Yeah. Where is this location? It's in the, if you had a look, if you read a bit more, it's in the computer's RAM, computer's main memory. In other words, the RAM. All right. So what else can we say about it? We saw that the value in the variable can be referenced. In other words, we can use it. We can retrieve it. Retrieved. It can also vary. That's why it's called a variable. As in, we can change it. It's a variable. What else can we say? There's a ton we can say about this little thing. Because it's in RAM, or it's in your main memory, would it be there if you turn the machine off and turn it back on? Not putting your machine to sleep or anything. If you completely shut it down, would it be there? when you turn it back on, no, it has to be loaded again. So that's just the nature of RAM. So whatever that's stored in RAM also gets lost. Because it's in RAM, it's not permanent. So you might have to save it. All right. So all right, let's move on to the next one. Search online for what data type means. So same sort of drill as before. You search for data type, and here we go, data type. Shop around a bit, and you can even say data type and programming. You don't get too many different contexts for that one. You get this Utah website, and what else? Tutorials Point has something, and so on. Right. So in computer science and computer programming, a data type, or simply type, is a classification of data. What else do other people say? Because of this and that. Okay, all programs involve storing and manipulating data. Computer knows only. Yeah. Okay. So that's a bit of a roundabout way of saying things. Let's discuss a very simple but very important concept. Data types, as it type of the data which you can process using your computer program. So this one says it's a type of data which tells how the programmer intends to use the data. So let's stick to those two examples. Let's take the Wikipedia article, give the URL for the Wikipedia article. In your own words, the Wikipedia article said a classification of how the programmer intends to use the data. Classification of how the programmer intends to use the data. This one is from Tutorials Point, and what is it saying? Represents a type of the data which you can process using your computer program. Represents a type of the data that you can process using your computer program. All right, so that's it. You just have to write it in your own words. Now let's just move on to the next question. I will talk about data types tomorrow during the lecture again and go into a bit more detail. So the next thing is this. Search for what an integer means and write it in your own words. Okay, so let's search for integer. Integer. And what did I type? Integer. Right. Yeah, okay. So integer, again, find different examples, but here we go, another one, take target or something. All right, an integer is a number that can be written without a fractional component. Okay, that's one answer. Here it'll say an integer is a whole number, not a fractional number, that can be positive, negative, or zero. Okay, so write it in your own words. An integer is a whole number. It can be positive or negative. What about zero? What can we say about zero? Is it positive or negative? In programming, zero is considered positive. So only if something has a negative number, a negative sign in front of it, it's considered negative, right? So what else? It does not have a fractional component, which is what both places said. That is, there are no decimal points, right? Just one whole number. And then when you want to explain it even better, always give some examples. Can someone tell me an example of an integer? Anyone? 5. And something else? 12. I heard 12. What else? What was that? Negative 4. Thank you very much. Negatives are also included. 0 is fine. Anything else? This number over here is an integer. It's a very, very long integer. And there are such things as long integers. But anyway, that's an integer. It's just a whole number. All right. Search for what a floating point number means. Okay, you do your search, and then what did people come across? What's a floating point number? It's sort of like the opposite of an integer, right? Yeah. It's a number with what? With a decimal point, right? And it can have, how many digits can it have after the decimal point? Sorry? Well, there's always a limit. It's limited by your memory, but it can be arbitrary. It can have an arbitrary number of digits before or after the decimal point, and the total number of digits is limited by the amount of space allocated for the variable. All right, so these are integers and floating point. Those are types. All right, that's what we started talking about, data types, and we know that variables are locations in your main memory. So we can also say variables have a certain amount of space allocated to them, right? And of course you have it's a container, right? We said it contains. Containers are of a fixed size, so what you can put inside it depends on how big that container is. So that's that applies to integers and floating point numbers. All right, that's enough. So let's move on to Java primitive data types. So if you search for Java primitive data types, there are 8. So now I saw a lot of people went with the first link. That's okay, but I recommend going to the Oracle website and going with their explanation whenever possible. Because why the Oracle website? It's because that's where you get Java from, right? So they have a good idea about Java because they are in charge of Java, right? So this is the official documentation. So here it says there are 8 different data types. The first one is actually done for you. Int is for integer. You can store integer numbers with that data type. And with byte, what can you do? Again, they are integer numbers. So that's all you needed to write. You didn't need to give exact details on things. So as you're just writing stuff, get something in there, write some answer and then expand on it afterwards. So we did int already. Then there is long. So remember how I said the amount of space allocated determines how big the number is. So a long is what we call a long integer. In other words, it's usually got twice the amount of space that an integer has. Again, these things we'll look at during the lecture this week on Friday. Float, this is not an integer number. What is it then? Is it a number? Float stands for floating point. So floating point are numbers with decimal points. So these are floating point numbers, okay? And double. So double is basically like how we say long for int. When we say when we want a long integer, double is a long float. Basically, it's a big float, so it's double the size of a normal float. Also floating point numbers. And finally, we have 2 different ones. Finally, Boolean. What's Boolean? Yeah, true. Oops, true or false. Now I wrote it in lowercase for a reason. You will see that eventually when you use those Boolean things in your Java programs, but they have only one of two. They can store only one of two values, like binary 1 or 0. Like, okay, not exactly, but works like that. Okay, so now char. Char stands for what? Character. All right. Examples of characters. Mickey Mouse. No, not those kinds of characters. What kind of characters are we talking about? Sorry? Yeah, no, I mean, like specific examples of characters. Character A, like A in your from your keyboard, you know, the lowercase a, and you can have uppercase A. That's a different character. The dollar sign is a character, and what else? 1 written like that is a character. It's referring to the character 1, not the value 1. So if you want to give an example for integers, we know integer examples, right? Like that. So floating point numbers examples, 0.5 or 4, and we didn't do that before, but even 0.0 is a floating point number. So floating point numbers will always have this point, dot. And true or false, these are the only two values that you can have for Boolean. And char, any character. It's not going to be treated as anything else. A doesn't have any other meaning than that thing. It looks like that, that's it. If you write 1, it's not the quantity 1, it's the character 1. Just like the dollar symbol doesn't have a quantity. It's just what it looks like. So that's all for this tutorial, and